Welcome back to algebra. Hope you all had a nice relaxing weekend. Welcome back to trigonometry. And so we're just gonna get right to it. Hopefully you took some time and you took a look at that other video that I sent you on the unit circle. I really hope you've been trying to at least memorize these coordinates and these angles. Your life will be so much easier if you do. You can also take the time to color code this. If you color code when you're trying to remember it, the colors will come back to you, and sometimes that helps too. Now, if you have these memorized, I can sum this lesson up in 30 seconds. We're talking about sine and cosine, and I'm going to get into all the SOHCAHTOA and all that stuff. But if you can remember cosine and sine, that is any coordinate. So this is your x and this is your y. Notice it's in alphabetical order, just like x and y. So if I said, what is the cosine of 30 degrees? This is your cosine, this is your sine. So the cosine of 30 degrees is the square root of 3 over 2. Every single coordinate is cosine, sine, cosine, sine, cosine, sine. If you can remember that, you're in excellent shape. I'm going to go through this lesson the same way I went through the last lesson. The beginning of the notes is focusing on where the sine and cosine come from, SOHCAHTOA, and I am going to get into that, but for those of you who just like to memorize, I'm going to do this part first, and then we can go back in a minute.
Can you type in
So you should either have handy your shortcut of angles, the way that I put them at the end of lesson 2, or the unit circle that was given to you today that hopefully you filled out. If you have that, your life will be a little bit easier. So you, again, just need to remember that any coordinate is defined by the cosine and the sine. So the x value is the cosine, the y value is the sine. Exercise 2 says, using the unit circle diagram, determine each of the following values. So it wants to know the sine of 30 degrees. I need to know what my 30-degree angle coordinate is. Well, that is the square root of 3 over 2 and 1/2. Now 30 degrees is in which quadrant? It's in quadrant 1, which means everything's positive, correct? So what I'm now going to do is, because I want the sine, that's my y value, which is that. So that means my sine of 30 degrees is 1/2. So next we have the sine of 240 degrees. Well, 240 degrees is a 60-degree angle. And it may be helpful if you need to just kind of sketch a graph, right? 240 is here, so that's quadrant 3. So a 60-degree angle is 1/2 negative square root of 3 over 2. Excuse me, they're both negative because we're in quadrant 3. So again, we are talking about sine, so that is the y value. So my answer is negative 3 square root of 3 over 2. I'm going to zoom in and erase just so I don't have everything all squished like I just did. So I'm going to do C, cosine of 90. And if you remember, 90 degrees is right here. Well, the coordinates right there are 0, 1. Now be careful, a lot of you on your last homework were getting the coordinates that are directly on the axes backwards. All right, so that's 0, 1. If you find it confusing, you're just going to have to memorize them like all the other angles. Now, we are talking about cosine. Cosine is the x value. So in this case, the x value is 0. 0 is a number, the cosine of 90 degrees is 0, and that is the answer. All right, part D, the cosine of 180 degrees. Well, 180 degrees is all the way over here. It's a straight line, and the coordinates there are -1, 0. Again, I am talking about cosine, which is the x value. So my cosine of 180 degrees is -1. All right, the sine of 90 degrees. Again, the 90 degrees is there. The coordinate there is 0, 1. The coordinate does not change, but I am talking about sine this time. Talking about sine. So that's my y value. So my y value here is 1. On F, I have 135 degrees, which is somewhere in the second quadrant. And it is a 45-degree angle. So those coordinates are the square root of 2 over 2, the square root of 2 over 2. Now, because I'm in quadrant 2, my x value is negative. That is where most people may mess up, is where things are negative, especially when we then have to state the sine or the cosine. However, in this case, luckily it wouldn't affect it too much. I'm looking for the sine, which is my y value. Well, that's terrible looking too. Let me just fix that. So the sine of 135 degrees is the square root of 2 over 2. Now we're looking at the cosine of 150 degrees. That is also in the second quadrant. 150 degrees is a 30-degree angle. So the coordinates of that are the square root of 3 over 2, 1/2. And because we're in the second quadrant, my x value needs to be negative. Now we're talking about cosine, which is the x value, so that negative really does matter here, okay? So my cosine of 150 is negative square root of 3 over 2. If you didn't have that negative in there, it would be wrong. Now looking at the cosine of 0, this one always throws people off. Well, where is 0 degrees? It's nowhere, right? It's like you never even left the axis. It's also the same as 360 degrees, right? So this is 0 degrees here. Well, what's the coordinates there? The coordinate is 1, 0, which is the same coordinate as 360 degrees. And I'm looking for the cosine, which is the x value. So the cosine of 0 is 1. On the second page, exercise 2 says, for each quadrant below, determine if the sine and cosine of an angle whose terminal ray falls in the quadrant is positive or negative. So the thing about this is, you know, a lot of teachers want you to memorize this. In my opinion, it's kind of just like common sense, right? I don't know, that's just the way I look at it. But, you know, you might want to memorize it, but okay, so what they're saying is if I land in quadrant 1, my sine and cosine, are they positive or negative? Well, anything in quadrant 1 is positive, positive, correct? On the contrary to that, quadrant 3 isn't both values negative. So your sine and your cosine are both going to be negative. Those are the easy ones to remember, right? Now in quadrant 2, one of them is negative. Which one? Well, the x values are negative because you're towards the negatives on the number line. So that is your cosine. So that's negative, and your sine is positive. And the exact opposite of that, quadrant 4, Your x is positive, but your y is negative, which means your sine is negative and your cosine is positive. All right, the next little section on the Pythagorean identity. I'm not sure why that translated a little funky. Look, in the formatting's a little messed up, but it says for any angle of theta, the cosine of theta squared plus the sine of theta squared equals 1. This has a new name, sort of. Pythagorean theorem, you know when an identity is when the left side equals the right side, right? And they're kind of putting it together. However, what this should also hopefully look like to you, we just learned that the cosine and sine are x and y values, right? So if this was an x and this was a y, what is this the equation of? A circle, that's right. And doesn't that make sense? We are doing the unit circle. So the radius is 1. The center is 0. So even though it looks new, it looks crazy with that theta in there, it's exactly the same as the circle equation and what we did in the last lesson where we had to find the x or y values. Now we're finding sine or cosine, which is exactly the same. So an angle alpha, again, we're dealing with Greek letters. It is alpha. It sort of looks like an A or part of an infinity sign. I don't know, but that's alpha. All right, an angle alpha has a terminal ray that falls in the second quadrant. Now, this is the only thing that's going to be slightly different here. This piece of information is going to be important. Really not till the end, but it is important, so get in the habit of highlighting it. If it is known that the sine of alpha equals 3/5, determine the value of the cosine. All right, so we know that the sine is 3/5, which means we know that y equals 3/5. They want us to find the cosine, or x, really, and we know that it's equal to 1. So I'm going to write it out using the identity formula given. So I have cosine of theta squared plus the sine of theta squared equals 1. I am now going to plug in my sine. Now I'm writing the cosine of theta squared again, but really we're going to just treat it like an x. So I have 3/5 squared equals 1. So I have cosine of theta squared. So I'm going to square that, so I get 9/25 equals 1. And I'm going to subtract the 9/25 from both sides. So I have the cosine of theta squared equals 16/25. And do that on a calculator if you need to. Now, if I'm treating the cosine of theta like an x, I basically have x squared equals 16/25. So all I need to do at this point is take the square root of both sides. So the square root cancels the squared. So the cosine of theta equals, now you can write plus or minus 4/5. That's what I was looking at on the last homework. However, we are in the second quadrant. This is where that comes into play. So we are somewhere over there. I am talking about my x value. Now, I like to do it logically, but you may want to go up here and take a look at this. We're in quadrant 2. And notice my cosine is negative. I logically just like to think that my x value is negative in the second quadrant, but whatever works for you. So, and this is where everybody messes up, right? You do all this beautiful work, you get this perfect answer, but you have to say that it is negative. If you don't say that it's negative, then you will not get full credit. Exercise 6. An angle theta has a terminal ray that falls in the first quadrant and the cosine of theta equals 1/3. Determine the value of the sine of theta in simple radical form. Now, I would like to point out this part right here. You should always pay attention to that. I love when it's the first quadrant because we know that no matter what, your answer has to be positive. Now, they want us to find the sine. So again, I am going to use the formula, the Pythagorean identity. And I'm going to plug in what is given to me, which is the cosine. So I'm going to plug that into there. So I have 1/3 squared plus the sine of theta squared equals 1. So let's square the 1/3, so that gives me 1/9. Okay, I want to get the sine of theta by itself, so I'm going to subtract the 1/9 from both sides. And that's going to give me the sine of theta squared equals 8/9. I'm going to take the square root of both sides to get rid of that. So I have the sine of theta equals. Now, my 9 is a perfect square, so that's nice and easy, but my 8 is not. I saw in your homework a lot of you put this in decimal form. Be aware, you're really going to see directions that say simple radical form. So off to the side, I'm going to do the square root of 8. Well, what's the largest perfect square that goes into 8? It's 4, right? 4 times 2 is 8. So that's going to give me 2 rad 2. Now, normally I would say you'd put plus or minus, but we know that it's in quadrant 1, which was given, so it stays positive.
Are you crying? No. Are you crying? Are you crying? There's no crying. There's no crying in baseball.
Why don't you leave her alone, Jimmy?
Oh, you zip it, Doris.
All right, so this is the harder part sometimes to wrap our head around. It's where the sine and cosine functions come from in terms of the unit circle. So a brief little recap from geometry, SOHCAHTOA. The definitions are kind of at the beginning. I just remember SOHCAHTOA. So to find the sine, it's the opposite over the hypotenuse. And then to find the cosine, it's the adjacent over the hypotenuse, right? And then the tangent is the opposite over the adjacent, which is also really like dividing the sine by the cosine, which we do get into a little bit later on, but today we're just going to talk about sine and cosine. A little refresher. If you have a right triangle, the hypotenuse is always across from the right angle, and it is always the longest side, no matter what. Now, as far as the opposite and the adjacent, if this is the angle I'm talking about, the opposite is the one that doesn't touch it. So this would be the opposite. And the adjacent means next to. So that would be the adjacent to that angle. If I was talking about the other angle, the opposite and the adjacent would switch. So if this was my angle, I'll just use the alpha there. So the hypotenuse is not going to change. It's still across from the right angle. But the opposite is the one that doesn't touch the angle we're talking about, and the adjacent is the one that's touching it. So for exercise 1, it says consider the unit circle shown below with an angle theta. So please notice where theta is located, all right? Drawn in standard position. So it's a unit circle, which means that all the angles that we have just talked about are applied. Given the right triangle shown, find the expression for the sine of theta. So if we want to find the sine of theta, the sine is opposite over hypotenuse. So opposite over hypotenuse, okay? And if I look, the hypotenuse is 1. That's the one that's across from the right angle, so that's easy enough. And the opposite is the one that's not touching theta, so that would be the y. So the y is the opposite. Well, y over 1 is 1. So the sine of theta is y. Now, let's move on to finding the cosine. So if I want to find the cosine of theta, there should be a theta here. That is the adjacent over the hypotenuse. So we're still talking about the same exact angle, right? The theta there. So we're talking about the same triangle that has been drawn. So my hypotenuse is 1, and the adjacent is the one next to it. So that's my x. So the cosine of theta equals x. So that is where everything that we've talked about in this lesson has come from. Now, if you're wondering, well, where did that x and y come from that they labeled in the triangle? Like, why is it even there? Like, why, anybody could just put that there, right? What they did was they drew an angle. We do not know the degrees. Right now, it doesn't matter. Because we're on a unit circle, the length of that ray has to be 1. The radius anywhere on that circle, no matter what angle you draw, is 1. So then what they did was they marked this point right there. And we don't know anything about those coordinates whatsoever because we don't know the angle measurement. The only thing that we know is that those coordinates are xy. That's all we know. So then what they did was they said, okay, well, I'm just going to draw this straight line down here and form the right angle. So if the coordinate there is xy, the length from the center of the circle over to where that dotted line is has to be x. It has to be the x coordinate. Same thing that this has to be y. Do you need to know, do you need to have that memorized? No, but it is useful to know where it came from. All right, so work on your homework. I will have a live review session for you on Wednesday. Take care, everybody.